Hello everyone. Today we have a case study where we have a motherboard that seems to work and everything looks okay, but we don't have a display. The fan spins and everything looks okay, but we don't have a display and we don't have a keyboard light. Okay, so let me connect the cables to this motherboard and we'll try it. You can see it on this display if it works or not. Okay, so I connected the cables, the 12 volts and this ATX power cable. So let's try and power it on. As you can see, it works, but we don't have anything on this display. And the keyboard light here, as you can see in here, it does not light. This one in here. So let me check some voltages while this motherboard is on. Okay, so we have at the ATX connector, we have the 3.3 volts. We have the minus 12 volts. We have 5 volts. Okay. We have the standby. Where is the standby? This one. Standby 5 volts. And the yellow cables is the 12 volts. And we have the 12 volts. Okay. So let me just remove this fan and put it away from here. As you can see, the CPU is not getting warm, so I am assuming that we don't have a vCore voltage. So as you can see, we don't have vCore voltage, okay? So let me check some voltages around here, this motherboard. We have here 3.3 volts. And here we have 1.8 volts, which is good. Here we have how much? 1.5 volts for the RAM memory. Here we have 1.05 volts. Everything seems to be okay except the vCore. I have already tried and reflashed the BIOS chips, both of these two. Okay, you can see yes, these two chips. So why we don't have a vCore voltage? Let me switch everything off and I will explain it for you once more, because I have explained it in one of my previous videos, but let's do it again. Maybe we have more information about the vCore voltage. Okay. Okay, so in the previous video about the VRAM core voltage, we said that we have the VRAM chip that controls the voltage that goes to the CPU. This VRAM chip will drive MOSFETs. high and low MOSFETs, and the output goes through an inductor and then to the CPU as V-core. Okay, so let's say here we have the CPU. We said that we need some voltages for this VRM chip in order for it to work, to start working. We said that it requires VCC or Vin, let's say Vin. It requires ground. It requires enable signal, and we said it's called VR on signal. I don't know if you can see. Yes. Okay, so we said also that we have a sense line to the CPU that detects whether the CPU is installed or not. Okay, and also we have another line which is NTC, negative temperature coefficient, to test or to measure the CPU temperature. The NTC is within the CPU, and the VRM, which measures the temperature of the CPU. The CPU will not measure its temperature. The temperature of the CPU is measured by the VRM IC. Okay, so we know that we need V in to the VRM, and we need the enable signal, which is the VR on. We need the sense line that goes to the CPU and the NTC. There is also some different voltages and signals that you need to check. One is called, I didn't tell you this in the last video, but it's very important. One is called VCC IO, and one is called VCC SA, which is VCC input output, VCC SA. But these signals are not to be connected, to be provided to the VRM chip, but instead they are provided to the CPU. These voltages should be from 1.0 to 1.05 volts, both of these, VCCIO and VCCSA, and these two goes to the CPU, does not go to the VRM chip, but goes to the CPU. Before the CPU gets its V-core voltage, it gets the VCCIO and the VCCSA. Why the CPU needs these voltages? Because it has an internal microcontroller, or it's just like a BIOS that has some commands, and it needs to do these, to execute these commands. And it has a memory also for these commands. The BIOS, let's say it's BIOS. The BIOS and the memory needs a voltage. Why the CPU needs these BIOS and memory? Because the voltage that goes to the CPU through the VRM chip is controlled by the CPU itself. The CPU will set its voltages. The CPU itself will set its V-core voltage. And how is that? There is a communication lines between the CPU and the VRM. So let's write here VRM chip. Okay, this is, you will find it sometimes STA and SCL, which is the data and clock. These communication lines goes from the CPU to the VRM chip. And also there is one line called alarm. And it's active low. These 3 pins needs to communicate with the VRM chip. The CPU needs to communicate with the VRM chip in order for it to set its voltages. So we can say that the CPU enables the VRM IC to start and produce the VRM, the V-core voltage. Okay? So sometimes you will not find SDA and SCL lines, but instead you will find VID lines. VID lines. More than one line. Okay? And also these lines are the communication lines between the VRM chip and the CPU itself. When this BIOS start to work, when it gets its VCC SA and VCC IO, it start to work, then the CPU will send commands to the VRM chip to start and generate what the CPU requires of voltages. How much the CPU needs of voltages, of power, the VRM will start and produce it. So now we know that the CPU needs, before the V-core voltage, it needs VCC IO and it needs VCC SA voltages. There are maybe some other voltages like VCC GT, I think, which is for the graphic voltage, also goes to the CPU directly before the V-core. VCC also VCC ST, which is standby voltages for the CPU. All of these voltages goes to the CPU before the V-core voltage. So if you check here and you didn't find, and you did not find the V-core voltage, you might have a missing voltage, one of these voltages, or maybe the VRN signal is missing, okay, or the CPU itself is not good, or one of these MOSFETs are bad, or even this VRM chip itself is not good. Sometimes, in some cases, you will not find this VRM chip driving these MOSFETs straight away like this. You will find it providing a PWM signals to a driving IC for the MOSFETs. So this IC then will drive the MOSFETs, high and low MOSFETs. And this goes through inductor, and this will provide us with the V-core. Okay, so we have the VRM IC, but we also have another IC, which is a driver IC for these MOSFETs. It's not directly driven by the VRM IC in some cases, but in other cases you will find it driven straight away from the VRM chip. Okay, so we now know that we need to know and measure some voltages if we have a missing V-core voltage. We need to check the VIN voltage for the VRM. We need to check the VRN. Okay, we need to check these voltages: VCC-IO, VCC-SA, VCC-GT, VCC-ST, which is standby, graphics. This is called system agent, and input-output. These voltages should be provided first to the CPU, and then the CPU will set its voltages, through the communication lines. And we said that we have two different ways of communication lines between the CPU and the VRM chip. Either you find SDA and SCL communication, or sometimes you will find VID pins, VID pins. This goes to the VRM chip, and these VID or VID lines are just the same as the serial data or serial clock communication lines. And also we need to have to know this alarm or check this alarm. You need to have DSO to check this alarm, because this is always at high level. When there is an event, for example, the VRM detected a high temperature at the CPU, so the VRM will send an alarm, or will send this event to the CPU through this, will notify the CPU through this alarm. It will go down and then will go back up the alarm chip. Then the CPU will start communicating through this VID or the SDA SCL with the VRM chip to reduce its power. Okay, so I hope you now understand how this vCore voltage or vCore circuit works. So now let's go back to our motherboard and start checking some of these voltages. Okay. Okay, before we start measuring these voltages, let's go to the circuit diagrams and see how this IC works and what voltages it requires to start working. So now we have this circuit diagram. As you can see, this is the vCore IC. It's NCP6151. Okay, so as you can see, we need to have a VCC, which is the VIN voltage that goes to the IC. And we need to have enable signal. And we say that the enable signal is the VRON signal that comes from either the Super I/O or from the PCH. If this VRON chip, or I mean signal, comes from the Super I/O, it should be 3.3 volts. But if it does come from the PCH, then it should be 1.05 volts. Okay, but in this case we have another signal that is called hardware VTT power good signal. This signal works as enable signal for this IC. We don't have VRON signal in this case, in this IC. But instead we have hardware VTT power good. This hardware VTT power good is pulled high through this voltage divider to 12 volts. So if we measured, or if we calculated how much voltage we should have out of this voltage divider, I think it's around 1 volts, 1 point something volt. We will test it in the motherboard itself. Okay, we also said that we need this data and clock and alert. It's alert, not alarm. My fault, my mistake. It's alert. So it's data line, clock line, and alert line. This goes to the CPU itself to communicate with the CPU. Okay. And then we have PWM 1, 2, 3, 4 that goes to another ICs that drives the MOSFET. So this IC will not drive the MOSFETs directly. Okay. So let's go and check. We have here VR ready. This is as a power good. That means that we have the power, the VR core voltage. This signal will come out of this IC, will be produced after we have the vCore voltage. Okay, I think there is another one. This one, VR ready A. This is the for the graphics voltage. When the graphics voltage is good, this will go out. Okay, so let's go and check first for this VCC enable VR ready. Do we have the VR ready? I have the what's called board view of this motherboard. So if we check and let's go to the U8. So let's write U8. U8 is here. As you can see, so let's go back to the circuit diagram. So we need to check pin 10 for VCC. We need to check pin 9 for enable signal. Let's go to board view. Where is pin? Which pins? 10 and 9. So 10 goes to this capacitor here, and 9 goes to this resistor here. Let's go and measure this. We said that the 10 is the VCC and the 9 is the VR on, or in this case we said it's hardware VTT power good signal. Okay, let's go back to the motherboard. Okay, so let's turn on this motherboard. Okay, so the motherboard now is working. As you can see, the fan is spinning. Let's check the vCore once more. Do we have the vCore? We don't have the vCore. We still don't have the vCore. Do we have the 12 volts at this line here? So we have the 12 volts coming to these MOSFETs, but we don't have any output of these MOSFETs. So this is the chip that I was talking about, the VRM chip. I'll be using the microscope to check its pins. So we said that we need to check pin 9 and pin 10. So you can see how much voltages do we have here. Pin 9 is the hardware VTT enable signal. So we have 1.08 volts that enables this IC to start working. Do we have the VCC? We have 5 volts, so the VCC is okay, the enable signal is okay. But we said that we need to check other voltages like VCC IO, VCC SA. Let's go back to the board view and search for, the circuit diagram, and search for the VCC SA, VCC IO, and check them. Let's try VCC SA. Do we have anything that says VCC SA? Okay, so we have here the VCC SA. So this IC which generates the VCC SA here. How does it generate it? It uses this MOSFET. This MOSFET is from this side, from the drain side, is connected to the CPU VTT. Let's go and check, do we have the CPU VTT? I think this should be 1.05 volts. Let's try and search about this. C568. Okay, so it's in here. Let's go back to the motherboard and check it. Okay, so the VTT, CPU VTT is at this capacitor. So let me check it. Do we have 1.05 volts? We do have 1.05 volts at this capacitor. Okay, I hope you can see it in here. We have 1.05 volts, so the CPU VTT is good. Let's go back to the circuit diagram and check. Check this MOSFET, because this MOSFET what provide us with the VCCSA. Okay, so this MOSFET is being driven by this IC, which is NCB 102 IC, and this IC needs enable signal, ground, feedback, VCC drive, which goes to the MOSFET, and soft start. The enable signal is enable VCCSA, so this is the enable signal for the VCCSA, and it comes through this resistor, and it's the hardware VTT power good, the same one that goes to the VRM chip. We measured this at the VRM chip and we found it 1.08 volts, which is good. We will measure it again here at this IC. First we will check, do we have the VCCSA? If we don't, then we'll start and measure everything that corresponds or this IC requires. Okay, so let's go and check the VCCSA, which is connected with this capacitor EC61. EC61, which is this one in here. Okay, let's go back to our motherboard. So as you can see, we have this capacitor here that provide us the VCCSA. So let's check it. We don't have the VCCSA voltage. As you can see, we don't have the VCCSA voltage. Let's go and check that IC, which is the NCB 102. Okay, so we said that we don't have the VCCSA going to the CPU. So what generates this VCCSA is this MOSFET, and this MOSFET should be driven by this IC. We checked this CPU VTT and it's there. So now we need to check what this IC needs in order for it to start driving this MOSFET. So it needs the VTT, hardware VTT power good at the enable pin, which is pin number 1. We need the VCC at pin number 6, which is 12 volts. And we need to check this capacitor whether it is shorted to ground or not, because this is used as soft start. So this IC will start charging this IC slowly, then it will start driving this MOSFET to prevent spikes. Okay, so I will go and check the enable signal VCC drive. If the drive is good here but it's not good in here, so this resistor might be bad. Also, if the enable signal is good in here but not in here, so this resistor should be bad. Let's go to the board view and search for this U10. So here we have the U10 that drive this MOSFETs, the Q97. We said that pin 1 is the enable signal, enable for the VCCSA. This is the hardware VTT power good. Okay, so if we can see in this resistor here we have the enable for the VCCSA, and the other side it's hardware VTT power good. I will go and check either in this resistor or this is resistor for 1.08 volts, and then I will check also at pin 6 for VCC, which is 12 volts. Also we can check it at this capacitor. Okay, so then we have the drive pin, which is pin 5 that goes through this resistor, and from, is it pin 5? Was it pin 5? I think, yeah, it is pin 5. So we will check pin 5 and then we will check it after this resistor, because this resistor goes to the gate of this IC, of this MOSFET I mean. Okay, so let's go back to the motherboard. So here we have the U10 IC. I will be using my microscope to check it. I don't know if you want to see it under the microscope. Let's go to microscope. So here is the IC. This is the IC. This is pin number 1. This should have 1.08 volts. This pin 6 goes to this capacitor. This should have 12 volts. And this pin 5 that goes through these two resistors, from this resistor goes to this gate of this MOSFET. Okay, so I will switch back from the microscope so you can see the multimeter, but I will be using the microscope. I don't know if you can see the multimeter. Okay, let me check. So pin 1, we said that pin 1 is the enable signal, the VTT, hardware VTT power good. We said it should be 1.08 volt, and as you can see in the multimeter, it's 1.80 volt. We need to have a 12 volts at this capacitor. So we have 12 volts, as you can see. We need to have at pin 5 a driving voltage that drives this MOSFET, but we don't have the drive voltage. Okay, so that leads me that this is a bad IC. But first I will check that capacitor that's connected to the soft start. Just let me switch off this motherboard. So this is the capacitor. From this side should be ground, from this side should be not ground. So this capacitor is okay. So I think this IC is not good, the NCB 102. I will change it and then we will see if this sort out our issue. Okay, now so I replaced this NCB 102 IC that drive this MOSFET. So let's try and switch on this motherboard again and check if we do have the vCore and this VCCSA. Okay, I won't let it running for a long time because I don't want to hurt the CPU because it might get hot. So do we have this? Yes, we do have 1.9 volt. Do we have the vCore? We have the vCore, which is 0.2 volts. I'll switch it off now. I will connect the heatsink and I will test it again. Okay, now I have installed the heatsink and connected everything that needs to be connected. The display cable is connected and the keyboard is connected, and applied thermal compound to the heatsink. So now let's try and turn it on and see if we will have a display on that display. So let's turn it on. And we do have a display. So as you can see, we managed to solve missing vCore voltage and a power on no display issue. I hope you enjoyed this video. If you learned something and you like it, please don't forget to like it, share it, and subscribe to my channel. Thank you for watching and see you in another video.